The name of this video is grounding. Suppose to go back to the problem of two conductors, a system of two conducting materials. This is capital gamma 1. This is capital gamma 2. These are full materials here, bulk materials, with vacuum capital omega. That's the way we called it, in between. We know, for example, that the charge Q1 associated with capital gamma 1, or better, on its surface, can be computed by the knowledge of the self and cross capacitances. So in this case, C11, the self capacitance of capital gamma 1, times the electrostatic potential V1 on that equipotential surface, plus C12, the cross capacitance between the two, V2, the electrostatic potential on the second equipotential surface, capital sigma 2. So suppose that I want to measure experimentally this quantity here, C12, the cross capacitance. Same applies for the self capacitance 1,1 and also for the self capacitance 2,2 if you want. How do we proceed? Well, in order to solve this problem, we need to first ground. This is the symbol for grounding. And I will come back to this in a few seconds. So we need to ground capital gamma 1, which allows us to set V1 to 0. So by doing so, operatively, that is experimentally, we can find C12 as Q1 divided by V2. And you see I've chosen a more complicated one, the cross capacitance, because I have Q1 divided by V2. Similar for all the other capacitances. Okay, what does it mean actually to ground the problem? So this is what we do in the lab to estimate one of these capacitances. But what is the physical process of grounding? So let me explain this down here a little bit more in detail. So suppose to have an object, let's just call it capital gamma for simplicity, which is conducting material in microscopic electrostatic equilibrium, let us say. And suppose that this object is characterized by some positive charge, let's say 1, 2, 3, 4 positive charges on it. Okay, just to count them, I keep a number like 4, a small number, a simple number. Now, the way we ground this, let's say this is a block of copper, okay, like this, and I want to ground it. To ground it, actually, you need to put it to earth, which means, typically, you take a copper wire, very thick, and this copper wire, you stick it to the ground until this copper wire, which is eventually attached to a copper rod, you attach it here, copper wire to a copper rod, and this copper rod you put in the ground until you touch water, so there is a good connection to the earth. Okay, so that's the physical procedure to ground. But what is conceptually this concept of grounding? So how does it actually work? Well, let's begin with a simple scenario. So we connect this object here to, by means of a very tiny wire, okay, with a wire, we connect it to a tiny object here, to another tiny conductor, okay? So in this case, and this is in fact in one of the home assignments as well, this kind of concept, what happens is that the total charge is to be conserved in this system, but I add another conducting object here. I will not give you the details here, I want that you think about it. But what happens is that if this is pretty small, of course it depends exactly on the geometry, etc. But for example, you can cook it up in such a way that one of these charges goes away from this capital gamma object and resides on this small object here. Of course, charge is conserved, I still have 4 charges, 1, 2, 3, 4, just one migrated to this small object. Now what happens if instead of having a small object like this is my copper wire and I connect this to the entire Earth, which is pretty big compared to, let's say, a block of copper like this. So in this case, this is also a conducting object if you want. In this case, this is so huge compared to this volume here that all those charges, all of them, migrate from this object onto, so now we're going to have 1, so forget about that, 2, 3, and 4, they all go to this reservoir, which is the Earth. All right, now to understand why the electrostatic potential goes to zero in that scenario, well, let's look at the simple case of a sphere, just to fix the ideas a little bit here. So if I consider a simple case of a sphere, of radius capital R, this is the center of the sphere, well, we know that the electrostatic potential right on the surface of this sphere is going to be given by whatever charge we place on the sphere divided by 4 pi epsilon naught capital R, which is the radius of the sphere, is an equipotential surface. Now, if we set our Q to be exactly equal to zero, and for example, how do we set that? Is by connecting this object to the Earth. So the Earth gets all the charges, whatever charge you put after reaching equilibrium, it goes all on the Earth, so it's gone from there. Well, obviously, the electrostatic potential happens to be also exactly equal to zero. And that's how we can implement such a scenario to ground this object to the Earth, so that this potential goes to zero, and we can isolate the C12, which is the cross capacitance we wanted to get. So this is effectively, conceptually, what it means to ground an object, which is really, really important in pretty much all experiments in physics. That's it.